Welcome to our 9th Arma Reforger modding bootcamp. This is the second in a series on animation. In this one, Senior Technical Animator Théo Escamez gives an introduction to the animation editor and will set up a new reload animation for a rifle. Take it away, Théo.
Hello everybody, welcome to this animation graph presentation. So as said, today's presentation is going to be split in two parts. The first part is going to be a presentation of the basics and fundamentals of the animation editor, at the end of which I will try to create live a small graph with some logic of the character to put in practice what we will have just learned. And the second part will be implementing new rifle animation to try to see, in conjunction with the next presentation about scripting, how this works, like how to set up signals from script with the animation and so on. So the first part about the animation editor, I guess everybody sees my screen. So this is what you are presented with the first time you open the animation editor. You have like four main quarters of the window, and each one of them has several tabs that you can switch to here. So I have prepared a little graph for presentation, and first I will start presenting some of the main tabs of the animation editor so that everybody is clear about what's what. Starting in the bottom right here with the graph window. The graph window is basically where you will create your logic, add your nodes, connect them, and do all of your base logic basically for your graph. You have a little search bar here that can be very useful if you're looking for specific nodes. You can right-click anywhere to create new nodes, and you can double-click on any node of the graph to start evaluating from the node. And as you will notice in this window, the nodes that are being evaluated are highlighted in orange. This will be important for later. But that pretty much wraps it up for the graph window. This is a pretty simple one, so that's where you will be creating your logic. Then we can switch to the viewport window on the top right here. This is where you have your preview model or models, and you will be viewing what's happening in the animation in real time. This is in this viewport. I'm going to turn this off. We're not going to talk about this today. So it doesn't have much, but a few things. This icon here on the top, the blue circle with two bones, if you click on it, it will bring a list of all the bones that are present in your preview model so that you can actually show them if you want to check that everything's in place or that your bones are animated as you intended. You can auto-select children if you want to show a whole chain at once, just quality of life. If you do play an animation or if something is playing, on the bottom you will see a timeline here. You can scroll through the timeline, and if your animation has some events, this is where you will see what events this animation contains. And finally, also if you have an animation selected, on the bottom right you have this channels window here, and this basically tells you which bones are present in the animation that you are viewing, because we don't always export all the bones for every animation, so it can be useful to figure out exactly what is being animated on certain animation takes, especially if you want to try to recreate them. So you have this little channels window here in the bottom. That pretty much wraps it for the viewport. We will switch to the Animset. Here in the top left, we have the Animset. This window here is basically where you're gonna plug in the animation files to the animation graph. This is where it happens. So it's presented in the form of several grids, as you can see, or groups. We call them groups. Each group has a name, can be expanded like this. It has columns and lines, and each column and line creates an animation slot here. So a green dot means that you have an animation plugged in the slot currently, and a gray dot means that there is nothing plugged in. You can double click one of these animations, one of these green dots, to view it in the viewport window. You have a search bar, so this is not very useful here because everything is in the same screen. You don't have a million animations, but this can be useful very quickly when you have more animations, trust me. If you select an animation, on the top here you can also see the path and the name of the animation that is connected here. And here you have a little magnifying glass icon. If you click it, it will show you in the asset browser where the animation is that is plugged in this slot. How to create a new group, a new grid, it's simple. You have this little icon that looks like a folder with a plus on the top. Click it, it will ask you the name of this new group that you want to create, so let's call it Animation 01. Now we have created a new group. It comes by default with one column and no line. So the first thing you probably want to do is to create animation row. So you right click on your group here, create animation row, give it a name, and now if we click this little arrow to expand, you can see we have one column, one line, we have one animation slot. And by the way, you can also rename to, because by default the default column is called default, but you probably want to rename it. So you just have to right click your column, rename the column, and that's it. Then you can add as many rows as you want and as many columns as you want. And basically here you have empty slots. Now to plug in animations to these slots, you want to find your animations in the asset browser here, and you can either drag and drop the animation to the slot, or you can, in the file browser, select the animation, then here in the Animset, select the slot, and if you press this little icon on the top right here, it will assign the selected animation to the selected slot. So basically, let me delete that. This is how the Animset works, and this is how you reference your animation files to the animation editor. Next, after the Animset, we have the Workspace tab, which is another tab also here in the top left. So I will only go over very few things here. First, we have an animation instance here, examples.asi. And what animation instances do is that they contain a different set of animation for the same grids. The best is maybe to show you, so we'll quickly open the player graph from the vanilla game. And so, as you can see here, we have several instances: rifle, machine gun, RPG, this is an armed, right? So, if I go to the Animset and I look for a run forward animation, let's double click to preview it, you see I have an unarmed animation which looks a bit silly with the AK in hand, but let's forget about that for a second. We have an unarmed run, and here in the top of the Animset I can also change animation instance. So let's check the rifle animation instance, and you can see that the same slot in the Animset contains a different animation whether I'm in the unarmed instance or in the rifle instance or in the RPG instance. That allows us to maintain the Animset in a decent size and not having to create slots for every weapon type of every animation. This can be used in other ways, but basically this is to make categories of animation sets that needs to share the same grids and the same pattern. Okay, back to the example graph. Workspace. Next, we have the sheets. What is a sheet? It's basically a workspace for your graph. So here we have only one sheet that contains already some nodes, but you can very well, by clicking on the AGF file here, if you right click, you can add a new sheet, give it a name. And now in Sheets, if you double click a sheet, you will open it, and you see in the graph window it changed, 9 nodes disappeared. It's basically a different workspace, so you can separate your logic into different sheets. The important point is you can very well have a node in one sheet that is connected to another node in another sheet. There's no boundaries between the sheets, it's just for organization purpose to not have everything at the same place. Yes, so double clicking on a sheet will show you basically in the graph window what nodes, what logic it contains. And finally, for the Workspace tab, we have here the preview model that I talked about briefly on the Viewport. By default, when you create a new graph, it should offer you to already plug in a preview model. But if you did not do it, you can always come back here to your graph, right-click on preview models, and here you can add a preview model. So let's say I am looking now for a guy in USSR uniform. I bring it, and see now, you cannot have more than one preview model in the viewport, but you can have more than one preview model connected, and you can double-click on it here to switch it in the viewport between the different preview models. And also, I will not go into the details, but you can right-click an existing preview model and add a child model. That's how I had the rifle in the player graph earlier. You can attach a rifle. The rifle itself, though, beware, will not be animated. It will just be a static mesh. This is just for visualization. So yeah, that is the Workspace tab. And finally, about the tabs, I will quickly talk about the Controls tab here on the bottom left. This is where you are going to create your different variables that you are going to use later in the graph in your logic. Let me expand that. So basically you have three main types of variables that you can create. You have the float variable, which is any number between the minimum and the maximum value. Then you have the integer variable, which is any entire number between minimum and maximum, so it cannot be any decimal. It will be 1, 2, 3, it cannot be anywhere in between. And finally, you have the Boolean variable, which is basically just true or false. It's a binary state type of variable. And so how that works, here you have the variables tab. If you want to create a new one, you have this little plus icon here on the top. It will ask you which type of variable you want to create. Let's say we want to create a float, so we choose float here. It asks for a name. Let's go with float03 because I already have float 01 and 2 created here. Okay. Now we've created a variable, and by expanding here, you can see the different settings that it has, which are default value, minimum value, maximum value. You will see that by default everything is at 0, which is not very useful. It's basically always going to stay at 0 no matter what you do. So you probably want to set a max value. Maybe you want the minimum value to be negative, maybe not 0, I don't know. And the default value is the value that it will have if you don't touch the variable when you start evaluating the graph. So that is for creating a variable. Here too you have a search window, and search window that works in a way that you should be able to search multiple things at once. That didn't seem to work here, but that's okay. And yeah, one last thing about the control window. So if you start evaluating the graph by double-clicking a node in the graph, as I showed earlier, you will see that its appearance has changed. That is what it looks like when evaluating the graph, and that's what it looks like when not evaluating the graph. So when you're not evaluating the graph, you're setting up your variables, and when you're evaluating the graph, then you can actually play with your variables and give them a value. So here, as you can see, the float is any number between minimum and maximum value that you specify, here 0 and 1. Then you have an integer, which is, well, integer numbers 0, 1, 2, 3, and Boolean, which is either true or false. You tick it. And that's it for the control tab, and that's it for the presentation of the few tabs that I wanted to present today. So now we're going to move on to the basic nodes, the most commonly and useful nodes that you will come across either by making graphs or looking at our vanilla graphs. Starting with the very basic building block of most graphs, which is the source node. The source node, pose node, the nodes, basically the source node, what it does, it has a single goal. It references one of the animations that you have in your Animset. So the animations that you plug in your Animset, they are not yet in the graph. To be in the graph, you need to create a source node and to reference an animation from the Animset in the source node. The way this works, let's create a new source node. When you select a node, by the way, on the bottom left, you will see that it always brings up the Properties tab. So when you select something, actually not just a node, it will always bring up the properties. And in the properties of the source node, you have a field called Source. And this is what you will be using to reference one of the animations. And the way it works is you will specify the name of the group, so let's say an idle, so idle, comma, the name of the column, comma, the name of the line. And this way you specify one specific slot. So let's try that. So let's say we want idle, comma, erected, because we want an erected idle. And you see it's already finding them, so I can click here. And now I have plugged idle 01, which is this animation here, into this source. So let's see if I start playing the source. Yes, it's in the correct pose. Amazing. One more thing about source node, you will notice that here I have a run, and then it stops. So also in the properties, you have here the loop type, which you can set to either loop the animation or not loop the animation. This is pretty straightforward. Some animations like locomotion you want to loop. Some animations like actions or emotes or whatnot, you probably don't want them to loop. In that case, we have a run, so we want it to loop. So now if we try again and evaluate the node, we can see that it will keep repeating forever. So these are basically the base functions of the source node. It's just you link an animation from the Animset. Now in the same vein, we have the pose node. The pose node works the same way in how you reference an anim from the Animset. You have the source here, group, column, line, and you will have a source. The difference is this will not play the animation. This will simply output a pose from the animation that you selected. And in the properties here, you have a time field. The time field tells you which time of the animation the pose should be taken. So 0 being the start of the animation, 1 being the end of the animation. You can choose any value. So if I change it here to 0.3, you see the poses have changed, because now it takes it from 30% of the animation. If I put 0.8, it will be a different pose, and so on. So that's the pose node. I will show you a slightly more advanced trick that you can do with the pose node. Here, the time field, if you on the right click these little two dots here, it will bring up a window that we call the expression window, the expression editor. This is a pretty powerful tool. And here, instead of using a static value, for instance, I can use one of the variables that I've already created in advance. So I have created a float variable already that goes from 0 to 1. So let's try that. If we start typing float, you see it even already recognizes that I have variables with this name. So you just need to select this one, float01, press enter, click OK. And now basically, instead of inputting manually a number here, I can start evaluating this node. And if I go to my controls panel on the bottom left and go to my float01, which I am now using to drive this time, see if I take the slider and move it around, it starts moving the animation because it gives a different value for the time according to the variable. So you can potentially use it like animate your variable via script and use it to scroll through the animation one way or another. So this was just to show that the pose node is not just to output a simple pose, it can be a little bit more advanced than that. And so these are the basic nodes that basically link to animations from the Animset. They are green. We have a color coding in the graph so that you can already recognize what's what just by taking a look. The source nodes and the nodes that link to the Animset are green typically. Now let's jump to the blend nodes. The blend nodes basically will be used to play one branch or another depending on variables and conditions and whatnot. I call these separating nodes because they usually have one parent and more than one child. They are yellow in the graph. Blend nodes, Q nodes, whatnot, they are yellow. So you can see again where it happens. So first, the simple blend node, it has two children, left and right, and it has in the properties here a blend weight. So the blend weight goes from 0 to 1, kind of like the pose node, but instead of playing the animation, what it does is at 0, the right branch here is not evaluated at all. And at 1, if the value is 1, then the right branch of the blend will be evaluated at 100%. So if we try this here, I will quickly change that. I will start playing my blend node that, as you can see in these properties, is also driven by the float01 variable that we used earlier. And you can see under the blend node here this little 0 that tells you how much of the weight there is. Currently 0 because my variable is at 0. if I start moving my variable, you can see that first the right node, which is not evaluated, is not highlighted in orange. As soon as I move the variable, it starts being evaluated as well. And in that case, what we have is a breathing additive animation on the right branch. So basically, the more I blend it in, the more I have breathing in the viewport. And the less I'm blending it, the less I have breathing up to nothing. So that's how the weight works. Now in the blend node, in the properties, you have one more option here, which is the optimization field. The name is absolutely misleading. Actually, what you can do here is you can decide to either skip blended out, which means that the branch that has 0 weight will not be evaluated. So if you have 0, the right branch will not be evaluated. If you have 1, then the left branch will not be evaluated. You have other options. You can choose to always evaluate the left branch, which means that no matter what the weight is, the left branch is always going to be evaluated, which is what we want in the case of breathing, because we want to play the additive breathing on top of the idle, and we want the idle to keep playing the left branch even when the breathing is at 100%. So it's situational. And you can choose to always eval right. I'm not sure if we ever use it in vanilla currently, but it's good that it exists, offer most possibility. And always eval both, which means that even if you have 0 weight, you will still be evaluating the right branch. Even if it doesn't output really any animation because you don't have weight, you will keep evaluating it. This is very situational. In that case, doesn't serve, and in most cases doesn't serve a purpose, but it can be useful in some very specific cases. So in that case, I will go back to always eval left, and we can control it with the float. One more thing, a blend, as I said, value 0 in the weight is 0% of the right branch, value 1 is 100% of the right branch. A little trick is you can actually exceed 100%. So I have another float 02, that goes from 0 to 5. Let's try to use it to drive the blend and see what happens. So if I move float 02, we can see as before, the more I put it in, the more I have breathing in my animation. But then I can go completely crazy, and if I go up to 5, you see this becomes ridiculous, right? But basically what I'm doing here is blending in 500% of the breathing into the animation. Can be useful in some situations. I just wanted to show that this was possible. You are not limited to 100%. Right, so that is the basic blend node. Now we're going to switch to the blend T. And the blend T works in the same way, in the way that it has one parent and one left and right branch. One of the big differences is that instead of having a weight, it has a condition. And this condition is either true or false. You are not going to be blending 50-50 two animations using the blend T. It's really when you want to play something different on the right branch for a while and come back, or condition based. So on the properties here, you can see you have condition, you have trigger on, trigger off. These are two options that cannot be used at the same time. You have to choose to use either condition or trigger on, trigger off. And you have additionally here a blending time, which is the time it will take to interpolate, to blend between two animations. I will leave it at 0 at first to show you what it looks like when it's at 0. So as you can see in the condition field here, I said that I can expand it again, very useful window, this one. I need the integer 01 variable, which is another variable that I created ahead of time. I need this integer variable to be equals to 1. And so if I start evaluating, if I take my integer variable and put it to 1, as you can see now, the right branch is being evaluated. In that case, we have two idle variations, so we definitely don't want to be playing both at the same time. So if you remember in the options here, I chose skip blended out instead of always eval left. So I'm in the right branch, and if I go back to 0 or anything other than 1, anything other than the condition, I go back to the left branch of the blend. But now, as you can see in the viewport, when I'm changing, it's really abruptly. In one frame, it's changing from one animation to the next. This is pretty ugly. So this is where this blend time comes in. So let's tweak it to say 0.3. This is in seconds, by the way. So this is 0.3 seconds blending time. So let's try again. I evaluate my blend T node. I take my variable, move it to 1. And now, as you can see, as I change, there is actual interpolation time. So it's not as ugly anymore to switch from one animation to the next. So that is blend T with a condition. I will quickly show how to use blend T with the trigger on, trigger off. It's really not that different. But here you can see instead of the condition I have trigger on integer equals 0, 1. These are also expression fields, by the way. Oops. You can Control Z. I accidentally deleted that. So integer 1 equals 1 would be the trigger on. And the trigger off would be if integer 1 is equals to 0. So let's try that. Let's start evaluating this node. We take our integer 1, move it to 1, and it starts playing the second animation. And as you can see, I also don't have blending time here. Silly me. Let's put some. Okay. But the difference is I can go above 1 and it stays on the right branch, because in that case the trigger off is integer equals 0. So I need to go back to 0 to go back to the left branch. And you see that's one fundamental difference with the condition here, where either it's equal to 1 and plays the right branch, or equals to anything else and plays the left. Now in that case you could obviously achieve the same thing in the condition by just specifying that you want it to be greater or equal to 1, and in that case with this condition on the blend T I can also bring my value to more than 1 and it will stay on the right branch. But this was to show the difference between condition and trigger on, trigger off. And that is the blend nodes. Next we're gonna jump on the group selects. I want to show you group selects because you will come across them quite a lot in the vanilla files, and I want to quickly explain what they do. What they allow you to do, if you remember, when I talked about the source node, I said you specify a slot from the Animset by specifying a group name, a column name, and a line name. Well, basically what the group select does is you can, in the group select, select a group name and the column name, and you can have different group selects with different columns of the same group, and they can all be connected to the same source node, or in that case pose node, but pose or source will work the same way. But the difference is, in your source or pose node in that case, you want to not specify the columns. So here if you check the source, I only have group name, comma, line name, and I completely skip the column. Otherwise it's always going to take the column from your source node, no matter which group select is evaluated. So let's take a look. Here I have a blend T with condition 1. So see what happens. Here I have a pose of an idle erected. Let's change the condition. And now I have the pose of an idle adjusted. We call that adjusted internally. And you can see, even though I have the same source node in both cases, the group select allows me to grab a different slot from the animation set from just one source. This is mostly useful when we have more complicated logic and we want to reduce a little bit the amount of nodes that we are creating. So this may not look very relevant when you only have 2 of them here and one source, but if you will open bigger graphs you will understand what I mean. And one more thing about group selects. Here I have a blend with a weight, which means I can blend 50-50 between the two. I don't have to be either or on each side, driven by a float. And as you can see, it can even blend 2 different animations together from the same source using the group select. So in that case I'm actually blending the 2 poses that we just saw, the erected idle and the erected adjusted idle, using the float and using the group selects. Right, so this was just a quick explanation of the group selects. Let's jump to state machines. State machines, they are basically pieces of logic that allow you to do a bit more intricate logic than the normal graph would, because the normal graph only reads one way from top to bottom, and that's it. And you have like a line of nodes, basically. In a state machine, I will show you how to create one. So right-click here, create state machine. This is what you get when you create a state machine by default. It has no state. So the first thing you want to do is, in this gray area under the node here, you want to right-click, create state. And now you have a state in your state machine. You can create more states. You can right-click on a state to create a transition. You can drag it to another state, click, and now these 2 states are connected by a transition. States have a start condition, but be aware that this start condition will only be evaluated the first time you enter the state machine. If you are already in the state machine, it is not relevant anymore with the start condition of the states because you are already in the state machine. In that case, the transitions will be important. So transitions, as you can see in the properties, they also have, here it's called duration, but it's also a blending time. So how long it takes to interpolate from one state to the other state. A start time, if you ever want to not start from the beginning of the animation, but from a different time, can be useful. And condition, same as the blend T. You have a condition, you can put anything you want here, a simple variable, a whole function that you will create yourself, or anything in between. And so that's how you create state machines. Let's jump to the examples. So here we have a state machine with an idle and a walk, which is actually a run, but it doesn't matter. We have this one with start condition true because I always want to start with the idle when I get to the state machine. And we have two transitions. So let's check the transitions. From idle to walk, I have a condition that integer 0,1 variable should be greater than 0. And once I'm in the locomotion, walk run, I need to get back to integer 0,1 equals 0 to transition back to idle. So let's give this a try. We double click. By the way, if you want to start evaluating a state machine, you cannot double click any of the state inside the state machine. That is not going to work. You want to double click this main node of the state machine here. So once we start evaluating our state machine, if we take our variable and move it to 1, see, now it transitioned to the walk/run state. And if we bring back the variable to 0, it goes back to idle. Pretty straightforward. And just a little tip also, you see on the viewport on top it's playing. You can at any moment press this play button here, which will pause the simulation. And in this case, you can actually scroll back to everything that you did if you want to check what happened in your logic, or if it took the correct transition that you wanted it to take, or whatnot. So this can always be useful. You can drag the timeline here. You can use the mouse wheel to go frame by frame. And yeah, so you can replay what you just evaluated here from the graph. Okay, so that was the first state machine. Second state machine, we will have a time-based condition. So in this case, we're going from an idle to a gesture. And so let's check our transitions once again. To go from idle to gesture, here we have a condition that says has variable changed to bool 01, which is a boolean variable. If you remember, it's true or false. And if it has changed to true. This expression here, by the way, you can start typing it here and it will whisper it for you. These are documented on our wiki, so you can find them online, all of them. So if the variable bool has changed to true, it will go to the gesture. Where it becomes interesting is in this transition. From the gesture back to the idle, if I select it, you will see I have a condition here, remaining timeless 0.2. What this means basically is once there is 0.2 seconds left of this gesture animation to play, it will automatically trigger this transition and go back to the idle. This way you don't need to have to set up a specific signal to go back, or no, just when the animation is finished, go back to idle. It can be very useful in a lot of cases. The only thing you need to know is if you're gonna use any time-sensitive condition in a transition or in a blend T node, they work the same way. You want to make sure to tick this post eval tick box here. Otherwise, it will not remember the time from the last frame, and you're just not going to be able to use time in any kind of condition. You can recognize a post eval transition by the dotted line here, as opposed to the full line here. So let's give it a try. So as we said, boolean 01 becomes true, goes to the gesture. So boom. Now we have a nice saluting gesture. And you see, once the gesture is finished, it automatically goes back to the idle state. So this is a time-based condition that you can use that can be pretty useful. States themselves, they have a time storage. I do not have time to explain that today. So take my word for it. For now, 90% of the cases, you want just to have real time here. You will see it by the little clock icon. you want to have real time. I just don't have time to go into the details of how that works today, so if you're creating a state machine, put all your states in real time. Now, lastly, we have another type of transition in the state machine, which is the from any transition. The from any transition, basically what it allows you to do is, instead of connecting the idle to the gesture state here, I have this little connection here on top of the gesture with the exact same condition that I had earlier, has variable change to bool 0, 1, true. But the advantage of this one is I can have a million different states in the state machine. I don't have to connect them all to the gesture. Instead, I can just have this one from any transition on top, and wherever I am within the state machine already, any other state or even itself, that can work as well, it will enter this state via this one from any transition. So that can be useful when you have more complex state machines to reduce the amount of transitions so that it doesn't turn into a spider web. So, but let's see how this works. It should really give us the exact same output as the previous state machine. So let's turn our boolean 0, 1 to true. Plays a saluting animation and comes back. Amazing, exactly as planned. So these were the basics of the state machines. And now that we've seen all of that, the source, the blend, group select and state machine, I'm going to try to create a small character graph just to show basically more useful and to show what we've learned in context of something a bit more practical. So if you look on the top left in the Animset, you will see that I have already prepared some sets of animations. I have a set of idles in erected and crouched stance. I have some locomotions, runs and walk in erected and crouched stance. And finally, I have some stance transition animations, erected to crouch, crouch to erected. And so from this, and just with the nodes and the conditions that we've learned, we're going to create a player graph that has idle with stance changing and two different types of speed, also with stance changing. So let's get to it. As I said at the beginning, your basic node is the source. You want to be able to play an animation first and foremost. So let's bring in a source node. We are going to link it to one of our idles. So if you remember, group name, comma, a column name. Let's start with the standing erected one and idle 01. So now if I take my source, it's the correct idle. And do not forget it's an idle to set it to loop. All right. Now let's say I have my idle and I want to connect it to the locomotion. So we will create a state machine on top of this source node. Create a state for the idle that we're going to call idle. Connect it to your source node. And you can set the start condition to true to make sure that you always start with this node when starting the state machine. You can create a second state for our locomotion. So let's click loco. Let's bring in a source node. Little tip, you can select a node or any selection of node, Control-C, Control-V, and you can duplicate everything. So I will select this source node, duplicate it because I'm a bit lazy. But in that case, I will want to plug in erected run. So I have a group called locomotion erected, and I want .run .f, which is the line name forward. So now if I play it, you can check I have properly a run animation. Amazing. So I can connect it. Perfect. Now we need to be able to transition between my idle and my locomotion. So we are going to create a transition from idle to locomotion. And in the condition, we will call a variable that I have already prepared called movement speed, which is an integer variable that goes from 0 to 2. But we're not just going to use it, we're going to want to have movement speed is greater than 0. In the condition here, we want some blending time, always. And we want a transition back from locomotion to the idle with the blending time, with the condition movement speed equals 0. So if you bring back your movement speed to 0, it's going to go from locomotion to idle. Let's give it a try. Double click your state machine, take your movement speed, go to 1, 2, okay, it runs, and when I go back to 0, it goes back to idle. Amazing. Now let's say we want to have walk and run, idle walk run. So that will be fairly easy. In that case, we're gonna use the group selects, because why not? So here in my Animset on the top left, as you can see in the locomotion, I have run and walk as different columns. So I can specify them in different group selects. So I can here create node, group select, connect here. We want the group called locomotion erected, and we want the column, let's start with the walk. Now we can duplicate it, Control-C, Control-V, but with the run column. And don't forget that if you're using group selects, you want to not specify the column in your source node. So here I want to go ahead, go to locomotion erected, comma F, and completely skip the column. Now to switch between these two group selects, I will need a blend node. Let's call in a blend T, because for now I don't want to blend between these animations, but directly from one to the other, and not be like 50-50 type of thing. So in the blend T, in the condition here, we know that in our left branch we have the walk, and our right branch we have the run. So we want that whatever condition we use here, if it becomes true, it will go to run. So we can have movement speed equals 2. Okay, let's give this a try. Evaluate the state machine, go to your movement speed variable. If I go from 0 to 1, I go to a walk. Oh, sorry, I didn't set my blend T correctly. I should skip blended out. I want to play either or left or right branch. So it's good that you see me making mistakes, because it'll tell you that it can happen and what to look for. So movement speed from 0 to 1 goes to walk, and from 1 to 2 goes to run. Back to 1 to walk, and 0 idle. I also forgot a blending time here. We want a blending time here. And there we go. So now we have idle, walk, and run. The next step now would be to add the crouch stance for all of this. So we're going to start with the idle. We want an erected idle and a crouch idle. In that case, I'm not going to use group selects. It's up to your own preference. I'm going to duplicate this source. But here, I'm going to link it to idle.crouch.idle01. So now this is a crouched idle, this is an erected idle. Amazing. But in that case, I'm not going to use a blend on top of that. It would create some issues. I don't have really time to get into these, because they are really like intricate issues. So just take my word for it for now. Instead, I'm going to use a state machine to specify if it should be erected or crouched that place. So let's create a quick state machine here. 2 state for 2 stances, 1 erected stance and 1 crouched stance. So ahead of time I have created another integer variable called stance that goes from 0 to 1, 0 being erected, 1 being crouched. So I'm going to use it here in the start condition of these states. So if we're erected, that means that our stance transition is 0. However, if we are crouched, then that means that our start condition will be stance equals 1. Okay. We connect these to the respective source nodes, and we connect this state to this state machine. Okay. But now, if I play the main state machine and I try to change the stance variable, nothing happens. Because as I said, the start condition of a state is only evaluated the first time you enter the state machine. But if you are already in the state machine, they are not evaluated anymore, so they are not gonna switch between one and the other. So one thing we could do is have these transitions between these two states, have a condition stance equals 1, or has variable changed to 1, they will work equally, and some duration, blending time 0.3. Transitions inside state machines, you can also Control-C on one, Control-V on another, and it will copy all the contents, except in that case I just want stance to be 0 to go back from crouch to erected. So let's give it a try. Now we are here. If we change our stance variable, it changes. It blends. It's not really pretty. And that's not how we are going to do it. Instead, we have animations for stance transition, so we're going to use them. So I'm going to delete these two transitions because I actually do not want to be able to go from one state to the other state while I'm in here. But in your main state machine here, where you have the idle and the locomotion, you can create a third state. Let's make a little bit of room. Move that down a little bit. That will be our transitions state. That's where we're gonna put our stance transitions. So in that case, we also have two animations. We have erected to crouch and crouch to erected. So we want to create a state machine that's very similar to this one. So I'm just gonna copy paste it here because again, I'm lazy and you should too. Now we have a state machine that has stance equals 0, stance equals 1, except in that case, we want to go from please select it, crouch to erected and erected to crouch. Okay, we will create some source nodes. So here we are going from crouch to erected. So we want to go to transition dot crouch dot go erected. Let's check if it's the correct animation. These ones can be a bit confusing. Yes, we have here an animation that goes from crouch to erected. Let's connect it, duplicate this node, put it under the other state, which is to go from erected to crouch, and link to the correct transition, which will be transition.erected.goCrouch. Double check, it goes from erected to crouch. And in that case, we do not want these sources to loop, so we leave it to no loop, and that's exactly as we want it to be. Now that we have this piece of logic for the stance transitions, we want to connect it to the idle. So create a couple of transitions, like we did for the locomotion. In this transition, blending time, again, always, and then in the condition, we can simply use has variable changed stance. What this does is if the stance variable has changed to anything, from anything, it doesn't matter, it will trigger this condition. It just needs to have change value. Yeah. And that's great because we don't need at this point to know which stance we're going to, we just need to know that the stance has changed to go from idle to the transition. And on our way back, and by the way, as I said earlier, always set real time on all of your states because no time to explain the intricacies of that. On this transition here, set a blending time as well, and here in the condition, we're going to use the remaining timeless that we saw earlier that will basically tell the graph to go back to idle once the transition animation is almost finished. Now, if I go back to my transition, open the condition, you will see I have a warning in the bottom. That is what I told you. If you use a time-sensitive condition, you want to tick the post-eval tick box here to be able to use the time. Shall we give it a try? Okay, now we are in idle. Let's go to our stance, change it to 1. So it played the transition, but as you can see here, it doesn't come back to the idle even though the animation is finished. This is because in state machines, if you want to use something such as remaining timeless or basically exit this state here because of any condition, you have a tick box in the property of the state that is called isExit. You can see now it has a reddish circle here. That means that this state is allowed to exit because sometimes you may want to, let's say, change several states one after the other and only have the last state of the chain exiting when there's no time left. So that can be useful. In that case, we want both states to exit. So give it a try, evaluate our state machine, change our stance. Amazing. Now we go to stance transition and back to idle. We can try to change back to erected. That is great. Now we have one last thing to put in, is you see if I go to locomotion by changing the movement speed, I do not have a stance. That's a bit annoying. So let's fix that real quick. Move that a bit to the side. So once more, we will need a state machine that is very similar to this one, so we can duplicate it. Except in that case, we want to be able to blend from erected to crouch or crouch to erected directly within this state machine. So we are going to create these two transitions that I showed earlier with some blending time, and here we are going to crouch. So let's say we want stance equals 1. Okay, we can copy, paste. That did not work. Copy, paste. But here change to stance equals 0, which is the erected stance. Now here we only have logic for erected locomotion, since we're taking it from the group locomotion erected. So let's do the same for the crouch locomotion. Duplicate this whole piece of logic here. But here in the group select, you want to change the group from locomotion erected to locomotion crouch, which is another group that I have prepared ahead of time with crouch locomotion. And also in the source node, do not forget the source node. We want to specify here locomotion crouch dot f. So now let's connect the erected stance to the erected logic, the crouch stance to the crouch logic. Connect this state to this state machine, and let's give it a go. Now, if I go to locomotion by changing the movement speed, it will work for both walk and run. I should be able to change my stance, and as you can see, now I'm freely switching between crouch locomotion, erected locomotion, and idles. If you're not happy with how fast it is, you can always here change your blending time to say 0.5. And now if I change the stance while in locomotion, yes, I have to start evaluating again. If I change the stance while in locomotion, it takes a lot longer, maybe even too long, but it takes a lot longer. So you can just change here your blending time to tweak how long it takes. But basically here, with just what we've seen earlier, we've managed to create a piece of logic that contains a character idle, character locomotion, and stance transitions. And in the end, I hope I managed to make it pretty simple, because that's what it is. It's just a collection of many simple steps, and I'm trying to teach you the simple steps because we simply cannot go and explain every single feature of the game one by one. So what I'm trying to do is give you the knowledge to be able to open any animation graph in Fusion and be able to read it like you would read a book, and being able to figure out by yourself what it contains, how it works. Because a lot of times, even if you open a vanilla graph, you will look at it, you will want to apply it to your own mod, but some specificities will make it not possible, and in that case, a brute explanation of the feature will just not help that much. So I'm really trying to bring the comprehension of how the graph works to a certain level. And so yeah, so that wraps up our first part. I had made already a mock-up here, as you can see, of this logic, a bit different, but pretty much does the same thing. Now we can switch to the second part, which should connect to the next animation presentation, which will be about scripting. I am going to show you how to plug in a new reload animation to an existing or modded weapon graph. So I created a small reload animation. Disclaimer, this is not some kind of like reveal or something. This is just an animation that I did specifically for the purpose of this talk. You are probably not going to see that in the game, yeah? But okay, so now I've made a tactical, as I call it, tactical reload, which would just like use one magazine to remove the next. Very popular, you see it in a lot of games. So we're gonna try and put this into a graph. So first, as you could see, I created it for the AK, so we are gonna go ahead and open the AK74 graph. And this is a vanilla graph, so this is locked, you cannot change anything. However, what you can do here in the files on top left, you can duplicate Workspace. If you click that, it will ask you where you want to put this new graph. So we'll put it to the tactical reload, Workspace. We can still call it AK74, that doesn't really matter at the moment. Okay. You can rename any of the files to what you want. In that case, we're also not going to rename. And click duplicate. So it looks to you maybe like the window hasn't changed. However, now we are not in the vanilla graph anymore. We are in the graph that I just duplicated. That is not a vanilla graph, so we are free to edit it however we want as a modder. the weapon graphs are a mess. Please pardon me for the state of them, and don't like look too close at this mess here. We are going to focus on this state machine, which is where the reloads are happening for most of the weapons. So let's go back to what we learned just earlier. We want to start with the Animset. We have a new reload. We need to create new animation slots to connect these reloads to the animation graph. So let's do that just right now. We're going to create a new animation row that we're going to call reload underscore insert mag underscore tactical. So as you can see, now I've created a new entry here, a new line in this already existing animation group. So I can go ahead in my file browser here. Let's see. Yes, so I already have here some animations. I don't know why I have two. Oh, because there's the weapon one as well. Pardon me. So we're going to drag it, make sure that we are in the player instance. Remember, we have here two instances. We have an instance for the player that contains the character animations, and an instance for the weapon, which contains the weapon itself, the weapon animations, and they share the same animset. So before plugging in the character animation, make sure you are in the player instance. Go to your file browser and simply put it here. So now in my Animset, you can see I have this new tactical reload. And we can do the same for the weapon itself. Go to your file browser, take the weapon animation, and plug it into these slots. Great. So I said I would not go into the details of that, but reload animations, vanilla reload animations, contain a certain set of events, animation events here, that are actually required for the game to function correctly. They should be pretty self-explanatory by their name: weapon detach magazine, blend out, weapon despawn magazine. I mean, that pretty much tells you what it does, but it needs to happen for the game to play this correctly. So I don't know if I will be able to do that since these animations are vanilla, but normally you can go ahead and copy paste events. Let me go back to the well, okay, I've already put them here, I'm sorry, but let's try again. Let's try anyway. Yeah, you see, I can simply, if I select the animation from the Animset, and the properties window is another place where you can see all the events here. And if you click on the event here and Control V after you already copied some events, you can simply paste them here. That will save you a little bit of time as opposed to create them all one by one. Another thing you can do is here in the timeline of the viewport, you can double click hold to move one event on the timeline wherever you want, or you can select it here in the properties and simply change the frame. Again, not going to go into the details, but basically you would want to check vanilla reload animations and probably have the same kind of events in your animation, same kind of moments. Event filter, just real quick. We don't care about the sounds, who are we? So you can either look for events or subtract events by using the subtracts sign before, and in that case you see I have like a bunch of sound events here that as an animator I don't really care about, so I can simply minus sound, and now you can see all the sound events have disappeared. So these are the events that will be interesting for you for the mechanical part of the weapon to work. Okay, so now we've plugged in an animation into our Animset. It's time to create a source, isn't it? So let's go ahead in our graph and create a source node, or we could duplicate an existing one. Let's link it to the group that is called reload. We are not going to specify a stance because there are group selects above in the graph, in the weapons graph, so we don't need to, and directly reload reload, a bit redundant, underscore insert mag tactical. So now if I check this source node, yes, we have the correct animation. Now that we have a source, we want to create states in the state machine, where you see you already have the existing states for the different reload animations, remove mag, insert mag. We're going to create a new one, call it tactical, whatever, doesn't really matter. Connect it to your source. Okay, now let's study the existing states. you will see that all of these states in their condition field have get command. I didn't speak about the commands, but basically they work. You create them in the controls. They are another type of variable that either send you an integer or work like a boolean. The only difference is they are only active for one frame and then they are forgotten about. Otherwise they work the same way. So here you want to get the integer from a command called weapon reload integer 2. And if we check each state, we will see that they all require a different integer. And this float is actually a derelict of the past. Really doesn't need to be there. I know this, you don't know this, but you know, like, just check here the integers. We see it goes, and we can check which reload uses which integer to like already make sense of it. But mostly we want to use a new integer for this new reload that is not used by an already existing reload. So by checking every different state here, I notice that the maximum value that is here is 6. Perfect. So let's try to use 7. I will copy this condition here, go to my tactical state in the, not in the start time, in the condition, start condition, paste it, but I want to change the integer to 7. Okay, and we probably want it to exit, because once the reload is finished, we want to exit this whole state machine and set it to real time. As I said, for now, that's what you'll do. So let's give it a try. Let's start playing the graph, and we want to try the command weapon reload with an integer value of 7. Ah, but nothing happens. How come? You can see we're in the idle state here above, and even though I tick this command, nothing happens. Because it's supposed to take this way here from idle to reload, these two transitions, and if I check this transition here from idle to buffer in the conditions, it has not in range weapon reload 7 to 9, which means that if the weapon reload command is between 7 and 9, this transition is going to ignore it. The reason is that under barrel grenade launcher, the GP25 actually uses these integers for its own reload. So in that case, you cannot use it. No big deal. We can use an even bigger integer. Let's use 10. So in that case, let's see what happens if we play our graph. Actually, we can stay focused over there and bring our command weapon reload with an integer of 10. Amazing. It plays our tactical reload and exits. Now, weapons being what they are in Arma, you can reload your weapon when you still have bullets left, or you can reload your weapon when it's empty, in which case you want to rack the bolt after that. So to make that happen, we're going to create another state in this state machine that we're going to call tactical underscore empty, which will be used when your weapon is empty. We're going to connect it to the same state, same source node. It will play the same animation. However, we will not set it to its exit, because once the animation is finished, what we want to do is to transition to the rack bolt animation, which is this reload action bolt here. We can see that already there are some other states that transition to this with the same condition. So be lazy, be happy, copy, paste, and we have our remaining time condition. So once this reload is almost finished, it will go automatically to the rack bolt animation. And that's the case where I told you that maybe you want some states to not have its exit because you want them to first transition to something else before exiting entirely from this state machine. And we can give this one either, we can give it another integer, which is what I'm gonna do for the next talk. So now if we play the graph, again stay focused here, and play our integer with the value 11, our command with the value 11, it plays this one, and then transitions to the rack bolt. Great. Alternatively, we have a variable in every weapons that's called empty. It's a boolean variable that code uses to tell us if the weapon is empty or not. So in this state, instead of using a different integer for the starting state, I could simply use the same integer as the other tactical and empty, which is a boolean variable, true or false. When you just specify it like that, it means you want it to be true. So if the weapon reload is 10 and the weapon is empty, then it's also gonna go there. So you have options how to do that. We can give it just a quick try for the demonstration. So here, if I look for the empty variable, take it to true, and bring in the reload, and as I told you earlier, so you can do several search with a space here, and it will search separately the different keywords that you're looking for. So you have an empty and weapon reload, which is pretty convenient. So let's try to send the integer for 10, which is true for both of these states. Controls, integer 10, go. But it chooses this state because also the empty boolean is true, whereas this one doesn't specify it. So these are two different ways you can approach it. In that case, I think we're going to do two different integers. And basically, once we've plugged in this this new reload, that's where Mario will take over in the next presentation to show you how to, in script, to set up new integers for this reload to be able to trigger this new reload that you've just plugged in the graph. And I guess that will wrap it up for me today. And yeah, so that would be the end of the presentation for now. Alright, so thank you everybody for attending, and I hope this was useful for you. If not, then again, I'm always available on the Discord. Ask away. I will try to respond. I'm not always able to. Some other people will. Some other people from Bohemia. Some other amazing members of the community that have also learned some ropes will be more than happy to help you. Just shoot away in the animation channel, and everybody is going to try to help. Alright, thank you everybody. Have a nice day. Bye-bye.